Hi, everyone. Welcome. Azure Cosmos DB Live TV. Episode, what are we at? 29. I can't believe it. We're almost at 30. I'm Mark Brown. I've got with us again, Abinav. How you doing, sir?
Good, Mark. How are you?
Good. So this is kind of the second part of kind of our two-part discussion we had. So I had you on about a little over a month ago, episode 24, and you talked about the client-side telemetry that you can get from our Java SDK, and also from our you can get from our .NET SDK as well. And kind of the discussion really centered around kind of this life cycle of a request, right? And being able to trace what's happening during that request from the time it's issued by the SDK in your app to when it hits the server and then comes back. And you showed all of those little different pieces of the JSON that get generated, all the like the microseconds, I guess, of like queuing a request, creating the request, queuing the thing, and then gets dispatched and then processed and then comes back, and showed kind of how you use that to kind of debug and troubleshoot issues. And today you're going to talk about kind of the service side of that. So all of the data you can get from all of the log analytics that we have. And, as a cloud service, everything that customers do, every interaction, every request is logged, right? And we have all this telemetry that we use, whether to help with support or just to be able to monitor ourselves, our own service health, and also for customers. Obviously, we expose that through log analytics, right? And they can write queries for that, and they can create alerts on that kind of thing. And I think that's kind of the stuff you're going to show us today, correct?
Yeah. Essentially, what we're trying to see is, last time we spoke about this one specific component called transit time, and that's sort of when the client has fired off the request, and at this point, it's in transit. It doesn't know what's going on, and that includes hitting Cosmos doing whatever it needs to do on the server, and that response coming back. And so what we're going to look at today is just that one piece alone, and just get into as much of depth as we possibly can into just that one little metric that you see on the client. But what does that look like in terms of every single bit of detail on the server?
Right. And you can get, and you're going to show some really interesting information about the health of your own application and the data or the database and how it's performing. So why don't we get to it? I know you wanted to kind of walk us through. So you have, this is a kind of almost like a decision chart, I guess, right?
Yeah. So essentially, this is sort of like a flow chart that we would want to use if we're seeing high latencies, right? So let's say we saw high latencies across the board, essentially as a round trip thing, and we've looked at some of the client-side telemetry. There's nothing that stands out there really. There's no high CPU. There's none of that. There's just this one piece that says, I fired off my request to Cosmos. It's taking a while. What's going on? So at this point, we now want to see, is there anything going on the server? Is it actually a server-side issue? Or do we actually have an explanation for it? So we see high latencies, but it's actually justifiable in some way. And so that's what we're trying to look at here, right? So let's say we start off with just a blanket thing that says, oh, I have high latencies. And the next step is, are we actually seeing spikes in server-side latencies? And I'll get into some of those queries as well. Now, you might be seeing high server latencies, but it may not be everywhere. It might be restricted to just a couple of partitions. And we have visibility that goes all the way down to that level of granularity. So we can look at that also.
Got it. So this is these bubbles are going to help us kind of triage kind of what's the root cause for why is our request taking so much longer?
Yeah, exactly. And then there are some components to that as well where we may not necessarily be seeing spikes in latencies, but we might see other issues that could manifest as high latencies from the client's perspective. So you may just have throttled requests in that time window. And because you have throttled requests, the client might be making retries up to a certain point. And maybe we've actually been able to successfully process that request, within a certain number of retries. So the client never sees the failure. Now, of course, if they extract their diagnostics, they'll see that as well. But if they start here, this could be an explanation for what's going on. If we are getting throttled, then the next step is, why are we getting throttled? So is there a larger request volume in that time window? If we are seeing larger request volume, is that because there are specific operations that suddenly saw a spike? Is that expected? Is that not expected? Do we want to go and troubleshoot why we're seeing a sudden massive uptick in write volume? Where's that coming from? Things like that. On the other end of that, we could also be seeing things like, well, maybe my request volume hasn't actually gone up. Maybe the existing operations that continue to remain the same are suddenly seeing a higher RU consumption per operation. So I'm still doing 1,000 operations per second, but suddenly those 1,000 are consuming 50% more RUs than they were in the previous hour. So why is that? And that could be for a few different reasons. Maybe the size of my writes, my document sizes have suddenly gone up for whatever reason. Maybe I can justify that as well. Maybe that's not the end of it. Maybe I'm seeing more data coming back on my reads. So my queries are now bringing back more documents than they were in the previous hour or in the previous day or in the previous month. And if that's all the case, that might still be not granular enough. We might want to dig in even deeper and say, is that happening across the board? Or is that happening for just a few logical partitions? And let me go in and troubleshoot why that's going on. Maybe we can justify that too. Maybe one customer is suddenly seeing a massive uptick in traffic. So it's great. But that could potentially be causing some issues on the server side as well.
So that one there is going to be number 9 is essentially, do I have a hot partition?
Exactly.
On the well, it could be it could be request and or storage.
Yep, exactly.
Okay.
Exactly. And so if none of these really fit what we're looking for, the next step in that process is, are we suddenly seeing cross-region calls? So the server itself is behaving totally fine. There's no throttle requests. There's no hotkeys. Request volumes are flat. Payload sizes are flat. Everything looks good. But for whatever reason, some of my VMs, let's say in East US, have started making calls to West US. So when it gets to West US, the latency is actually fine. But now we're trying to figure out, why is that VM not able to talk to its local region? So at that point, it might be just a VM having intermittent connectivity issues. So our client is going cross-region. Maybe it's justifiable, maybe it's not. Maybe you want to take that VM out of rotation, and then everything is fine. So that's what this side of that decision tree looks like. And then, of course, what we want to see is, was that just a few VMs that started going to the next region? Or is that happening for all of my VMs in that region? So at this point, might be a bigger networking issue that we want to be able to troubleshoot. And if none of that fits the bill, then we really just want to see, do we have any server-side timeouts? So that could be another reason where we simply had timeouts that were retried, and then that ended up causing high latencies, right? So, and really, this is one example. I'm sure we could dig into even more detail, but this is sort of the
one
the
scenario
flow.
kind of, right? So,
Yeah.
right, like, hey, my requests are taking longer. What are all the possible things I should check?
Yeah.
Yeah,
exactly. So with that, I could jump into log analytics. And essentially what log analytics does is, it's another service within Azure that every other Azure service can actually push telemetry into. So Cosmos DB being one of the PaaS services, we've essentially said, if you want to look at metrics for every single request, you can certainly do that. You just have to hook up your account, your Cosmos DB account, to a log analytics workspace. And once you go into that workspace, you can run a bunch of these queries. You can take a look at what's going on. So in this case, what we're going to look at is every single one of those bubbles. We've got a query for each of those bubbles. And we'll see some interesting examples. And the way you would actually enable this, and I can show what that looks like as well, all that you're doing is you're going into the diagnostic setting for your account. And you're essentially saying, I want to push these metrics. So in this case, I'm looking at a SQL API account. So I don't have Mongo, I don't have Cassandra, I don't have Gremlin. I've got everything else. And I've specified a workspace that I want to push my metrics into. And I'll cover what these two options mean a little later as well. It's primarily a cost.
That's new, isn't it? That what
Yeah.
you're going to show? Yeah. Okay.
Yeah.
No problem.
But essentially, this is all that you'd need to do. And then once you enable this, you'll start seeing telemetry flow into your workspace. And then we can actually start looking at, what's going on, right? So if we look at the very first thing, so really, really high level, what we want to see is, I just want to see what my latencies look like. And I'm just going to chart that. So if I look at the last 2 days, this is what my server-side latencies look like. And as you can see, something interesting was happening here in that 6 a.m. to 6 p.m. window. Things came down pretty significantly after that, and life looked good. But we had something crazy happened here. Something actually took 6.5 seconds, right? So clearly, we had some high server-side latencies in this picture. And there's a couple of ways in which we can break this down as well. And what I can actually do is just provide a very quick overview of the kind of the information that we even have in log analytics. So what you're actually seeing here is every single operation being logged, and it tells you when this request came to Cosmos. And this is all in UTC. It tells you the name of the Cosmos DB account, so you can actually push telemetry from multiple Cosmos DB accounts into the same workspace. And then you can do things in your queries where you can actually filter out which account you're looking for and things like that. It tells you the exact operation that you executed. It tells you the mode that you used, whether it was gateway mode or connection direct mode. It also tells you the activity ID of the operation. So if you start seeing just some of these, depending on the operation type, where you're seeing some strange things happening, something that you're not able to explain, anytime a user creates a support ticket, something that would be really helpful is getting the activity ID, right? And of course, this is available through the client as well, so there's many ways in which you can get it, but this is one way of correlating what you're seeing on the client versus what's happening on the server. The next step is, of course, the user agent, and this is just the name that you give to the client instance that you happen to be using. This is actually another very good way to determine what's going on. So given that you can plug in your own name into the user agent, it's a very good way of separating multiple applications that are talking to the same Cosmos DB account. So if you had app 1, app 2, app 3, each of them could actually put their own name into the user agent, so you can actually see exactly which application was responsible for these calls and what was going on, right? The next step is us just saying what was the resource that you targeted. In this case, I was doing some sort of a read on the database, but you'll see a bunch of them with document and things like that, which is the one that we really care about. Status code. This obviously tells us whether this was successful, whether it failed, if it did fail, why did it fail, and client IP. This is probably the most vital. So if you're not able to set a name for the application, you can still see exactly which IP sent this request to Cosmos DB. And where this is really helpful is sometimes we might see one particular IP or set of IPs that are running rogue. For whatever reason, they're stuck in some sort of an infinite loop, some sort of an error condition that just keeps catching and retrying, catching and retrying. So it's hammering the system. And we can use this to identify who that guy is. You can also use this to determine if you're sending calls to your local region or not. So one of the things that you can also see is which region did we target for this request? And if you happen to know that this client IP is not in East US 2, maybe it's in West US, then you'd want to figure out, why is this guy going across and going to the other region for my account? Is it a misconfigured client? Did I not set my preferred regions correctly? Or am I having connectivity issues that are forcing calls from this IP to go to the next region in line, right? Some of the other things that we spoke about, of course, was what does my RU consumption look like? And we'll get into a few more charts and examples there. How long did this take on the server? 0 doesn't mean that it took no time. This is, for the most part, an integer, so anything less than 1 millisecond just gets rounded down to 0. That's really what that means. How large was the payload? So obviously for writes, this will be something larger. If you happen to be running a query or a read operation, you're not sending anything over the wire necessarily in terms of JSON. You're just getting something back. And how large was the response that went back from Cosmos to the client? And just a little bit more detail in terms of the partition ID, and we'll get into some more specifics on partition level debugging as well, right? And then obviously which database, which collection, what was the authentication type. In this case, I just used the primary key. If you happen to be doing things like AAD and some of that, MSI, stuff like that, you'll actually see that authentication information also show up here. So this is actually happening for every single request. So the level of information here is pretty rich. And for something like a tier 0, tier 1 service, getting this visibility is quite valuable.
Yeah, that's a lot of data, and we're logging that in every single request.
Yeah,
we're logging that data. So
and you do have the option to turn this on and turn it off ad hoc as well. So if you know something's going on and you want to do a debugging session, you can just enable it for a couple of hours, get some insight, see what's happening, fix the issue, and then turn it off if you just don't want to pay the added cost of having this running all the time. Right?
Yeah.
Okay, so what we've done so far is we saw that there's clearly some latency issues going on somewhere. And now what we want to do is we want to dig in and say, okay, is that happening across the board? Is it happening on all my partitions? Is there a specific subset of partitions where I'm seeing this? What's going on? And so we've plotted this again. And if you look at it, the guy that's running really hot has no partition ID. So this is likely going to be the gateway. For the other ones that have a partition ID, it's actually pretty low. So we should be okay. What we can do is we can actually look at the raw data as well, in addition to the chart. So right here, all of these gateway mode. So it's going to the gateway, and something's happening on the gateway. This guy looks like it took 1.5 seconds, 688 milliseconds. So latencies are clearly high, right? But if we switch to our direct mode scenarios, it looks great. I mean, we've got some jumps to 100, but it's still nothing like this guy that took 5 seconds to execute this. So we need to see what's going on there. Everything else here looks good. These are pretty good, extremely low, and then another massive jump right there on the gateway. So something's clearly going on. Either we're sending a different set of requests to the gateway that are expected to take this long, or there's something going on there that we need to actually investigate. Or at this point, because it's the gateway and because it's Cosmos, you'd want to open up a support ticket and have something resolved pretty soon, right? So that's the next step. If we went back into our decision tree, what we're saying is it is actually localized to something specific. It's not happening all over the place, and it's on the gateway. Now, if we come down a little bit, the next side of it is, well, what if that didn't happen? Did I have any throttle requests? Was anything like that going on? In this case, that wasn't really a problem. One interesting thing that we have in some of our open source APIs actually is we've got this concept of server-side retries, right? So what you can actually see there, if I can switch back at some point, I thought I had this. I guess I don't. Give me 1 second.
That's all right.
Let me run this here. So I'll run a quick query because on the Cassandra side, it's actually very interesting. I can show a very quick sample of what this looks like. If you actually did get throttled, then there's one way of actually knowing what went on. So in our open source APIs, we've got columns that are a little different, that are a little more tailored to how it looks when you're running Mongo or Cassandra. But we've got this guy here that essentially says, did I have to retry this request? So this is actually telling me that I did get throttled, and Cosmos DB on the server chose to retry these requests up to a certain number of times. And that's really why it led to high latencies. So there's nothing going on server-side, but you did get throttled, and we retried 5 times, and that's why your request took 800 milliseconds to resolve, right? So that's something that we can actually get as far as this guy here. The next step that we want to see is, well, if I did get throttled, did I suddenly see a jump in request volume in a certain time window, and what's going on? So here I do see some jumps. I see a massive, massive jump here. Now in this case, we didn't get throttled, so it's actually okay. But just for the sake of it, if we assumed that we did get throttled, I can then dig in deeper into this guy and see what's going on. So I know I've got some larger requests in this time window. And then the next step is, let me get the specific requests that actually spiked. So I've got another query for that. And then now I can actually see, what does my create volume look like? What does my delete volume look like, right? And this will actually tell me and I've structured my query in such a way, but this can actually tell me in every bucket of time windows how many operations of which type did I have. Right, so at some point I see some jumps here, and then some massive jumps here. So this is either some sort of a batch job, some sort of an ingestion job, something clearly is happening here. And if it's not expected, then I need to figure out what's going on. And of course, if it's not expected, I can continue to keep drilling deeper and deeper because I have information all the way down to a specific IP that is sending these requests to Cosmos. Right? So we're going to get a little, this is going to get a little interesting at this point. So now what I want to see is maybe I didn't have any massive spikes in request volume, but even if I didn't, are my existing requests consuming more throughput all of a sudden than they did previously? So I'm pulling in quite a bit of data, so this might take a second. There we go. So I'm seeing some interesting patterns here, right? Like all of a sudden my reads are coming in randomly. My upserts keep going up and down and requests in RU consumption. So if I look at the raw data, I'm seeing some interesting patterns here. So let me scroll down, right? So I've got these jumps here. Upserts are now 32. Reads suddenly spiked to 300. And then my updates came back down. My upsert also came back down. Reads are still at 300. So something's going on with my reads. Why are my reads consuming that much throughput? And then all of a sudden the reads drop down again. So what's going on? So is this expected? Am I just oscillating back and forth between reading small documents, reading large documents? Is that expected? Should I be concerned about this? Do I need to fix something in my data model? Same thing with upserts, right? I saw some that were much lower, some that I think I saw earlier were 5. Suddenly that jumped up to 100. So some good insight here, and this isn't aggregated, so this is every single request. And the next thing that I want to see is, why is that happening? Is it because my payload sizes are sort of all over the place? And based on this chart, it actually looks like they are. So if you look at my upsert payload sizes, they're kind of getting different. I've got some upserts that are 4 KB, some that are 25 KB. And upsert operations are more RU consuming than creates. So there's some weird pattern here, and maybe I can justify this. But this might also explain why I'm suddenly seeing higher RU consumption, right? And if this happens all the time, great. But if it's suddenly happening in this time window, at this point, I really want to look at it and see what's going on. So if you look at it right here, this is what the raw data looks like. I see some at 25, some at 4, and it's just all over the place. So that also gives us some insight into where and how this is happening. I can then drill into the reads. So do I see similar differences on the read path? And I do. Now my reads itself are separated into 2 pieces. I've got my queries and I've got my reads themselves. So the queries are actually okay. This is bringing back almost 4 megabyte. Well, the reads rather are bringing in nearly 4 megs worth of data. So I need to see what's going on there. My queries, on the other hand, are far lower. And then again, I have this situation with reads oscillating all over the place. So really need to see what's going on here.
So these are 5-minute windows, right? So
yeah,
is that what we're seeing? Okay.
Yeah. So what we're seeing is, in that 5-minute, or maybe it's a 10-minute window that I have, what is the highest response size across any operation that was in that 10-minute window?
Okay.
So for any query that I ran, what was the highest response that came back from Cosmos? And this is actually in bytes, I think. So this is 103 kilobytes right there.
How do you get a 4 megabyte response off
Yeah.
of a read?
Yeah. So
that sounds fascinating to me, since our max doc size is 2 meg.
Yeah. So this is something very strange. So I need to see what's going on there, right? But this probably, now this is also in bytes. So what is that? Is that bytes? KB? Yeah. So that's 4 megabytes. Yes, and then the next step. So this is probably the most interesting thing here, which is, do I have a specific key that is causing problems for me? So what I've actually done here is I've broken down every single logical key that I have, and this is really outliers, the physical partition that they're on, and the total RU consumption that they have consumed.
Oh, this is cool. I didn't realize it actually showed the logical partition value in here. I've looked in our monitoring blades or whatever, that it shows kind of the partition key, physical partition key range. But it doesn't. I've never seen it show this. So this is really cool.
Yeah. And there's clearly something going on with this guy. Like if we look at this guy in total has consumed over 1.3 million RUs, which is fine. I mean, we're looking at every single operation. But if you look at the closest second, and the reason this is blank is on query operations, if you don't specify the logical key in your request options, it won't get logged. So that's really what's going on here.
So those are cross-partition queries, basically, when they're blank. Oh, that's interesting.
And so this is also okay, but this is across a whole bunch of logical keys, still nowhere near this guy. And the next closest partition key that consumed anything is this guy, who's at 11,000, which is nowhere near 1.3 million. So something is going on with this key, and I need to figure out what's happening, right? So the next step would be, is that also happening on the storage side of things? So I can also look at storage metrics to see, is this hotkey only hot from an RU consumption standpoint, or is there a lot of data that has come in for this guy as well? Clearly something is going on there, because this guy, even in terms of storage consumed, is far, far higher than anybody else. So clearly I have a hotkey, and that might be the root cause of a whole bunch of problems that I have. And so at this point, we've gotten a lot of good insight pretty quickly. And typically we see things like this where, you have you might be partitioned on customer ID, for instance. And for the most part, your customers are very well distributed, very nice request volume, good storage. And then all of a sudden you have one customer that's your whale customer, and that customer just hammers your throughput. And so you might want to rethink how you want to model for something like that.
Yep.
Right. So and then the next step is, let's assume we didn't have any of that, or maybe even in the presence of that, what we want to see is, did we have any server-side timeouts at all? And is that causing any problems? So in this case, we didn't, so we're okay there. And the last piece, which is, did I have any cross-region calls? This is actually interesting, because I did notice that I did have some cross-region calls, if I run the query correctly. Give me 1 second. So this guy, and what this query is really doing is it's saying, I want to get a count of operations per IP and in each region that this guy sent requests to. So if we look at this, for the most part, these guys are hitting West US and East US too. But this is an interesting client right there. So this guy sent requests to East US too. And then at a later time, that same guy sent requests to West US too. Right? Now, they happen to be close. But if I know that this client is obviously in just one of these regions, why were these calls actually going cross-region? Right? What was happening there? So that could be the root cause of my latencies, and we have that kind of visibility here also.
Yeah, because our SDK is not going to, it won't tell you necessarily, right? That's one of the benefits of Cosmos DB is availability. So we just will silently retry that request in another region if we can't access it. So and you wouldn't know. The only thing you'd see is, like you said, is, hey, why is that now taking so much longer? And so this is a cool query, definitely to troubleshoot. Is that happening, first of all, and then you can dig into why.
Yeah, and what we actually see is, in terms of the dashboards, that any service that's considered tier 0, tier 1 that would want to build on top of these logs would essentially say, How do I look at percentage of calls that stayed local? How do I look at time windows when I saw a jump in cross-region calls? And you can do the same thing. You can do that for RU consumption. You can do that for payload sizes. You can break it down by partitions. You can actually have a dashboard that simply says, I'm going to look at hotkeys from a storage standpoint and from an RU consumption standpoint and build dashboards off of that as well. So you can actually have these logs flow into Grafana, build Grafana dashboards. Those would be pretty real time, and that'll give you a lot of insight into what you want to do. Right?
It's just 5 minutes is the delay, isn't it?
It's actually, for log analytics, it's less than a minute.
Oh, is it really?
Oh, yeah.
Okay.
So that data is going to be in there almost as soon as the request went to Cosmos.
Yeah, a minute. That's okay. That's cool.
Yeah. And so that's essentially one example of how we would troubleshoot something like this. And of course, as I mentioned, we have this for all of our APIs. So the example that we walked through today was primarily SQL API. But there was that one query that we ran somewhere at the top that actually showed us what it looks like for Cassandra, where we could see server-side retries. And we have this for Mongo. We've got this for Gremlin. We've got this for tables. So you can do it. You can do it everywhere, right? One of the things that I actually wanted to highlight here was that we've made some pretty significant improvements to this entire thing. So if we go back to this blade, you'd see two options here in terms of the kinds of what that destination table needs to look like. So do we want data to go into Azure Diagnostics, or do we want data to go into resource-specific tables? And the difference primarily is this. So if we did Azure Diagnostics, the queries would look a little different. It would look like this instead of looking like this. And the big difference between them really is what we noticed was that Azure Diagnostics is actually a central table. So every Azure service is sending telemetry to Azure Diagnostics. And because of that, there's a bunch of additional metadata that's also going into that table, which can hog up more storage, and then essentially it'll eat into your cost as well, especially given how high volume a service Cosmos can be.
It's quite expensive, isn't it?
Yeah.
Especially, and then since it's logging every single request, if you're using Cosmos for high volume, high throughput database, that's going to start writing. It's going to fill up quick. I mean, and start costing you a ton. So.
Yeah, exactly. And what we noticed was that there was plenty of room to, cut down some of that extraneous information. There were certain additional things that we needed to do in there as well. Like if you had a column that had RU numbers, for instance, which is supposed to be a double, and we were sending that also as text. So you now had to parse that, convert that into a double. You had to do some complex stuff if you wanted to build some sort of a latency dashboard. Or an RU consumption dashboard. Any numerical value required a little bit more work. So we've cleaned up all of that, removed the extra information. And what you actually see is there's a very interesting way to look at that. So one of the things that we have is we've got this column in log analytics. You don't see it by default, but it tells you what your build size was just for that row. So what it really means is if we look at just a single row of telemetry, right? So we go all the way back, and let me just run this guy. Right? So for each row of telemetry, we can actually determine what the cost was just in terms of bytes. So I can project this column that will tell me something like this. Right? For each of these rows, it came in, what was my billable size? And in this case, I'm looking at about 276 bytes that this row just consumed. And I can do the same thing on both sides. So I can do that on the old version, which is Azure Diagnostics. I can also do that on the new version, which is the tables that start with CDB. And I can look at what those differences look like, right? So if I run a few of those queries, so let me just compare data plane. So we look at data plane in the new model, and it's consuming about, I don't even know what this is, 81 million bytes across 260K operations. If I look at the same thing on Azure Diagnostics in the same time window, so it's literally the same requests that I've pushed to both, right? So the request counts are essentially the same. I think one had 40 more requests or something like that, right? But now what we're looking at, this is 155 million. This is 81 million.
Wow, so nearly double.
Yeah. So we've essentially cut this in half with the new pipeline. But if you look at the metrics per row, it's exactly the same. It gives you all the vital information. It tells you which account this information was for, connection mode, the time that we generated that request, user agent, latencies, RU consumption, partition IDs, all that is still there. But we've just cut out some of the additional stuff, which was in some ways duplicate, that we just didn't need. And that's what we've brought it down to, right?
Seems like it makes your queries a little simpler to look at too.
Yeah.
Resource specific. I mean, you don't have to filter for the request for the.
Yeah, it's actually a very good point. Yeah, because now I don't have to
category.
say, just tell me what my data plane stuff, right? Yeah, it's actually a very good point, because now when I try to determine what my savings are in all the others, I have to very specifically go back to the same table and say, nope, just get me this. And we can run these too, right? So if we looked at what it looked like for partition key stats, we're getting 68 million bytes. If we do it in the new platform, this is actually going to be even lower. It's 18. So this is less than a third at this point. It's almost 1/4 of how far we've cut it. So if we go into the next one, we look at RU consumption. It's going to be about the same. So 84 million something. Let's look at RU consumption here. It's about 25 million. So this is actually less than a third, I think, if I'm doing my math right. It's well below. And the request volumes, as you can see, are the same. So the rows of telemetry are essentially the same. It's about 214K with some change. But we've brought this down massively. I'll do one last one, and then I'll actually do an overall view. So this is what it looked like for queries. Now, we don't have too many queries there, but even from the ones that we had, what did we look at? So in the new platform, it's 112K. In the old platform, it's 259K, so more than double. And just to be clear, when I say 112K, that's not dollars. It's the bytes of storage that was consumed.
Storage, yeah.
And I have one last view where I'm now looking at all these categories combined to look at total data consumption in that time window. So we're looking at 311 million and something bytes. And if I did that here, we are looking at 127. So this is more than a 60% savings. So it's pretty massive. And yeah, that's essentially the full spectrum of this.
That's, hey, it shouldn't have to cost you an arm and a leg to get at this data. So I definitely think that the newer resource-specific tables are the way to go. I think they're it's just easier, right? Like I can just go in and just like if I just want to analyze my queries, I can go in and just click the queries, analyze those. Or if I'm looking at very specific things, I mean, I don't, if I'm not using Mongo or Cassandra or Gremlin or whatever, I can just turn on those analytics that I need to see and when I need to see them. And then try to either, if I'm reproing something, or just turn it on and leave it on and use it that way if I'm using dashboards on top of this. So this is very cool. I'd love to get you back. I don't know. Are you like? I like the idea of like building dashboards, like Grafana dashboards on this stuff. Is that something you'd be interested in? Maybe coming back some other time. I mean, queries are cool and stuff, but dashboards is where it's at, man.
Yeah,
you can go and it's. I don't know. It for me, I'm visual, right? So I want to see. I can see things. I think most people are like that, right? They can see things better.
Yeah.
When there's something wrong. I wanted to just kind of put up a link. So pretty much everything you showed is all up in our docs, right? And so people can start right here, and I'll leave this up for a moment for our docs, Microsoft.com, and then they can start right here And then you can go into, so that goes into the monitor with diagnostic logs, but a lot of the stuff you showed, like troubleshooting issues with basic queries, and then troubleshooting issues using advanced queries. There's also control plane logs as well. So you can do diagnostics on like, hey, did somebody increase the throughput to 1 million RU or something like that? And if you're using AAD, you can even find out who was doing that, or creating new collections or databases or whatever. So you can also not just look at the data plane and the data that's coming in and out, but you can also do this on the control plane as well. So anyway, we've got great docs on all this stuff, and you can get and look at these samples here, and it's definitely worth it to go and you're using a managed service. This isn't running on a VM. You don't use the same types of tools. You've got to use diagnostics and monitoring and the tools that we provide to help monitor the healthier service or the healthier applications on there.
Yeah, and there's just one very quick call out that I wanted to make is that, given that we were talking about cost savings, one of the additional things that Log Analytics is actually working on is a filtering feature for the end user. So the user can actually come in and say, I want Cosmos DB to send logs to Log Analytics. I know Cosmos is going to send requests or send telemetry for every single request, but then I want to inject my own filter in there and say, I don't care about anything that's more than, or anything that's less than 100 RUs. So if it's consuming less than 100 RUs, it's not even an outlier for me. I don't want to see that. Just remove that and only push the logs to the final destination that are consuming more than 100 RUs per operation. You can do that.
That's even cooler and even better for cost savings.
Exactly.
Because you got a lot of noise that obviously, if every request is getting logged, that's a lot of noise you've got to sift through when you're looking for that needle in a haystack, so to speak, right? So
exactly.
Yeah.
And so that'll add to more savings as well. Realistically, we're looking at sometime early to mid next year. It's something that we've been partnering with the Log Analytics team on getting out there, but that's another thing that we're very excited about, and hopefully we'll be able to get out pretty soon.
So sometime next year, you say?
Yeah.
Okay. Yeah. Okay. Very cool. I just put that link up there for the docs just in case anybody missed it. You can take a quick screen cap of that. And then next week, we've got Matthias is back on. For those of you who know, Matthias works on our .NET SDK and had a pretty good episode when he was on Abinav. It was he went through, well, what doesn't he go through? It's everything, right? Like all the tips and tricks for our SDK, what all the response codes are, and what those mean. It was great. But next week he's going to join us. There's a new preview out. I don't know if you've seen for our Azure Functions triggers. So the V3 triggers are now out, which is great. They're now working or running off of our V3 SDK. The old ones ran on our V2 SDK, so we're pretty long in the tooth, if you will. We needed to get those things over to our newer SDK. So now we've got the new ones out. Those are in preview. Matthias is going to be on, and he's going to give us a rundown on those things. So definitely come and check us out. Oh, I think I see a couple of comments here. So thank you for sharing with us. Yep, metrics in the workspace is very helpful. Great. Do you have a question here? Is there an option to set an alert notification based on these matrix for RU increase?
Not through here. Actually, there's a way to do that through Azure Monitor, not on the Log Analytics side of things. Log Analytics is primarily for visibility. Something like an RU increase, you'd be able to see it, but you wouldn't be able to set an alert here. You could do that just through the regular Azure Monitor alerts for RU increases.
Yep, that's right. Azure Monitor, that's where you can set the thresholds and then set an alert to go do something, send you an email, send you a text, do something like that. So, yep. Okay, well, thank you so much again, Abinav. Great having you on. And let's sit down and see if we can hash out a another show, maybe showing Grafana or some dashboard type of thing on there. That'd be just kind of fun, kind of visual goodness or whatever. So, all right. Well, thank you so much. And thanks everyone for joining us this week. We'll see you next week. Bye-bye.